diving into transformations today. And for the most part, our experience with transformation is going to be pretty chill until we get into specific equations like quadratics or absolute value or bigger polynomials. But as we're diving into this, I want you thinking about what parts of an equation change with each transformation. Okay. So we've got a couple different transformations that we're going to be looking at. We're going to kind of group them together. The first is a translation, which means our graph is sliding. Horizontally is left or right. Vertical is up or down. Okay. Now, this column that says definition, I'm going to ask you to think a little bit about how this works in terms of what's happening to the equation. I wrote equals. Maybe you should make that a little clearer. I'm just going to put what happens to f, because we're going to look at it in terms of functions. So horizontal translation, in this case, we're moving our graph to the right. And how we do that is one of two ways. If we are moving left, we do x plus the number. And if we are moving right, we do x minus a number. So something we need to remember is that in terms of an equation, x lies. It works backwards from what we think. Okay? So if you want to move something left, use a plus. And if you want to move it right, use a minus. Now, in terms of up and down, we're going to talk about adding and subtracting the way we normally would. Except for now, it's going to happen outside the parentheses, right? Here, this was specifically happening to x, and then maybe something happened after we add or subtract. But now we're going to do our thing first and then add or subtract. So it's whether we're inside the parentheses or outside the parentheses. Okay? If I keep scrolling. Reflections, right? Reflections, we think of a flip. In other words, we make a mirror of our picture. Now, across the y-axis, here's the y-axis, and our points flip from one side to the other. When we want to flip across the y-axis, what we do is we make x negative in terms of the equation. If we want to flip across the x-axis, right, and find that mirror image point, then we take and we make the entire function. And make that negative. So you'll notice I don't have any x's when I'm doing vertical or when I'm reflecting across the x-axis, because the entire thing is what's getting added to or multiplied or made negative or whatever. Okay, so that's a flip. Now we have stretching and compressing. I'm not going to worry too much about horizontal stretch and compress, at least not what we're going to do to it. I feel like x was maybe a bad choice. Let me do this instead. We're not going to stress about the equation, but horizontal stretch is best probably captured by those pictures, right? Either we are grabbing it by the edges and making it wider, or putting our hands on it and squishing it together, right? Compression is basically just a squish. Okay, vertical stretch, vertical compression, both of them are done by multiplying a number in front of our function. And we're going to dive into this a little bit more in Desmos, and I think that'll make your life a little bit easier. A stretch, A is bigger than 1. A compress, A is smaller than 1. Okay? So the way we modify these equations, all this stuff in this kind of green middle column, is going to come up a lot this year, right? And so as we practice it, hopefully you'll have the opportunity to see how it all fits together. But basically, adding and subtracting, I'm going to add some things down here at the bottom. Sorry, give me 1 second to write in blue. Adding or subtracting is for translations, which are our slides, right? Sliding left, right, up, or down. Anytime we do an add or subtract, that's what we're doing. Making things negative tells us we are doing a reflection. And when we multiply, that's a clue that we are stretching or squishing. Okay, so those are kind of some clues. We're just going to get familiar with the language, have the chance to practice a little bit in